What is the difference between value data types and reference data types? And does it matter? Yes, it matters more than you'd expect. So let's dive in. In tech speak, a value data type is a data type that stores the value right at the memory address that is behind the variable name. A reference data type stores a reference to a memory address behind the variable name. This memory address is typically the starting point of the actual data structure. Why would this be done this way? One reason is that value data types mostly are data types that have a predetermined storage size requirement. Reference data types are data types that are dynamic, and hence the memory requirement is not consistent and can't be predetermined. The difference is how the data is accessed, and with that, what happens when you copy a variable. If you copy a variable holding a value data type, a duplicate with the actual content of the original variable is stored. When either is updated, the other is not affected by this, as they are independent, the same at the start, yes, but independent from each other from that on. If you copy a variable holding a reference data type, a duplicate of the reference to the start of the actual data is made. Let me phrase this in another way. There now is a second reference to the actual data. No data has been duplicated. Okay, so how can one visualize this? Consider a public library. When you enter, there are flyers and magazines in the welcome waiting area. These are like value data types. If you pick one up, wander over to the copier machine and make a copy, you now have two of these flyers. If you decorate one with your artistic work, the other is not affected. It stays the same. On the other hand, the books on the shelves in the library are the data stored in the reference data types. To find them, you have to go to a catalog. This can be good old-fashioned index cards, or it can be a computerized version. You find your book, you get your address. This is your aisle, your shelf, your bin, however your library is organized. Now, if you take this address and go to the copier machine and copy this address, you now have a duplicate of the address slip in your hand. But what happens now if you go to where your first address slip is pointing and decorate that book? I mean, besides that you deserve to get kicked out of the library. The book, or the data, that your second address slip is pointing to is also changed. This is because both slips are referring actually to the same data. Why is this important? Because this difference is actually the cause of far more misbehaving programs than one would expect. This is a polite way of talking about bugs. Let's say someone is passing a reference data type to a function, then this function is manipulating the original data, e.g. to get some sums over groups of data. The programmer intends to work on a copy inside the function. They make a copy right at the beginning of the function because of that. Now the data grouping is happening, the sums are built, and so forth. The results are returned to the main part. But because we have been working on reference data types, the temporary changes manipulated our data in the main part.
Rock and roll. Oops.
Now that you are aware of the distinction, you know how to do it correctly.
I got it. Look, some jerk didn't put.
I know what I
got it, though. It's
mean
on
when I
fire.
say oops. What do you?
And do try it again.
Yes, without the oops. Yes,
That way.
Voila, that is what we want. Okay, again, but without me interrupting the main show here.
Rock and roll. Oops.
Oops. What does that mean? What do you mean?
No, I got it. Look, some jerk didn't put.
I know what I
got it, though. It's
mean
on
when I
fire.
say oops. What do you mean saying oops there?
Well, you say we try that one again, huh?
Yes, without the oops. Yes,
That way.
And all this unintentionally because of using a reference data type like a value data type. What a difference. Now in Python, actually all data types are reference data types, but some, the basic ones, behave like they are value data types. At Saravji's Basecamp, you don't just learn Python. You'll build your foundations of programming. You can support by subscribing and sharing. Saravji's Basecamp is part of Saravji's Hut. For more details, head over to saravjishut.org.